my geometry friends. Today we are doing our first lesson with two column proofs. So we're going to be focusing on some new theorems from your dominoes. So if you flip to the front side of the second page, here I have highlighted in yellow it's really 4 theorems. The addition ones are kind of split up, and so are the subtraction, but we're looking at addition, subtraction, multiplication, and division properties. Now, the nice thing about these is for citing these properties as your reason in your 2-column proof, I'm not going to require you to write an if-then statement, but I am going to require you to tell me what you're adding, subtracting, multiplying, dividing, etc. So what do these apply to? We can use these with segments and angles. Each of these properties works for segments or angles. Addition works 2 ways. I can either add the same segment to 2 segments that I already know are congruent to get another set of congruent segments, or I can add 2 congruent segments to another set of congruent segments to get a congruent set of segments. This is the same for angles. I can add the same angle to 2 congruent angles, or I can add 2 congruent angles to 2 congruent angles to get angles of equal measure. So if you are adding either the same angle or congruent angles to congruent angles or segments, that is your addition property. Subtraction is similar, except we are going to be subtracting the same segment or angle or subtracting congruent segments or angles. Multiplication has to do if I have congruent segments or angles that I am multiplying by the same value, I'm going to still have a congruent segment or angle. And then division states that if I have congruent segments or angles that I'm dividing by the same value, I will still have congruent segments or angles. So addition, subtraction, multiplication, and division. It's going to be a combination of context clues and then just breaking down how we're getting to our end result to determine which of these 4 properties is being used. So let's practice that first. On our notes for today, number 1, if I'm given that angle TEV is congruent to angle XEW, and I want to prove that angle TEW is congruent to angle XEV. Now let's take a look at that. Each of those bigger angles is made up of 2 smaller angles. So angle TEW, that is angle TEV. Sorry about that bell. So that angle TEW is made up of angle TEV plus angle VEW. And angle XEV is made up of angle XEW plus angle VEW. Now I already know that these 2 angles are congruent because I was given that information at the beginning, and then VEW is the same angle. So I have added the same angle to congruent angles, meaning that this is my addition property. Another way that you could figure that out with context clues would be to say, okay, I'm going from a smaller angle to a larger angle, and I don't have keywords. I just have the congruence statement. Okay, let's look at this again on number 2. If AC is congruent to DF and BC is congruent to EF, I want to know how AB is congruent to DE. Well, let's analyze both of those. AB I got from taking AC, segment AC, and taking away segment BC. For DE, I started with segment DF and I took away segment EF. These 2 segments are congruent and these 2 segments are congruent, so I have subtracted congruent segments from congruent segments, meaning that this is my subtraction property. And my indication for that would be I'm getting smaller. I went from a longer segment to a smaller segment, and I don't have keywords. Again, I just have the congruence statements. Let's look at number 3. Angle KMR is congruent to angle VTW. And then I'm told that this angle KMO is trisected, which means it's split into 3 equal parts, and angle STV is trisected, which means it's also split into 3 equal parts. So how would I show that angle KMO is congruent to angle STV? Well, let's think about it. If I knew the measure of angle KMR, and I multiplied that by 3, that would give me the measure of angle KMO, because that's 1/3. It was trisected. Then if I took angle VTW and multiplied it by 3, that would give me the measure of angle STV, because again, it's been trisected, so that's 1/3. Well, these are congruent to each other by my multiplication property, because I multiplied congruent angles by the same value. And I spelled multiplication wrong. Multiplication. There's another C in there. There we go, multiplication. And my indication for that would be I was getting bigger, and I had these key words trisect in there. So let's look at number 4. I'm making a video. All right, if I have that angle AFE is congruent to DEF, so these two large angles are congruent, and they're both being bisected, how would I know that angle 1 is congruent to angle 2? Well, how would I find the measure of angle 1? If angle AFE was bisected, that means that it's being split into 2 equal parts. Same for angle DEF. Now, I've divided congruent angles by the same value. That means that those results are congruent, and this is my division property. And I know that I'm using division property because I'm going from bigger to smaller, and I have keywords bisect. Okay, so now that we're familiar with some of these properties, let's jump into a proof. So our 2-column proofs, we have our statements on one side and our reasons on the other, and we always number them so that we can keep track of which statement goes with which reason. So we're kind of easing you into this a little bit. We're going to give you some fill-in-the-blank ones. So here, part of it's done for you. And starting off, angle HEF is supplementary to angle EHG, and angle GFE is supplementary to angle FGH, and then I've got angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So the first thing it lists on my statements is that I have these 2 sets of congruent angles, and I know this because it's part of my given information. So the reason for number 1 and number 2 are both going to be given. Now, with that information alone, I can draw a conclusion. I am adding angle 1 and angle 2 and angle 3 and angle 4 together to get angle EHG and angle FGH, which become congruent angles by my addition property, because I have added congruent angles to congruent angles. So I know that angle EHG is congruent to angle FGH. Now, the next 2 statements are still part of my given information, so both of those reasons for 4 and 5 are going to be our given information. And I'm now on to my last part, my last statement and reason. Well, I can't end a proof until I've shown what I was asked to prove. So my last statement is always going to be our proof. And we were asked to prove that angle HEF is congruent to angle GFE. So let's look at what we know so far to determine the reason for this. So I just showed that these 2 angles are congruent, and then I used my given information that these 2 congruent angles are supplementary to these angles. Well, these are the angles I wanted to prove were congruent. So what do I know about congruent angles that are supplementary, angles that are supplementary to congruent angles? Well, if I look at my dominoes right here, if angles are supplementary to congruent angles, then they are congruent. So there is my if-then statement already written right there. If angles are supplementary to congruent angles, then they are congruent. And that finishes off our first proof. Let's do 2 more. Number 6. PR bisects QPS, so that's splitting it in half. KO is bisecting JKM, so that's splitting it in half. Angle 1 is supplementary to JKM, and angle 1 is supplementary to QPS. I want to show angle 2 is congruent to angle 3. Okay, my first 2 statements are written here for me. Those came straight from my given information, so those reasons are going to be given. Now, I have that angle 1 is supplementary to both of these angles. So a conclusion I can draw from that is that JKM is congruent to angle QPS, and my reason for that would be that I've got angles that are complementary to the same angle. If angles are complementary to the same angle, then they are congruent. Okay, so I drew a conclusion. My last statement is what I was trying to prove. Angle 2 is congruent to angle 3. So the other pieces of information I'm missing here is part of my givens. I know that PR bisects angle QPS, and I know that KO bisects angle JKM because that information was given to me. So if I'm ready to conclude that angle 2 is congruent to angle 3, how am I going to do that? Well, I know now that JKM and QPS are congruent to each other. So if I'm bisecting both of those angles, that means I'm splitting it in half. So to find the measure of angle 2, I would divide angle QPS by 2. And to find the measure of angle 3, I would divide JKM by 2. Well, if I'm dividing congruent angles by the same value, that is my division property. And that's going to prove that angle 2 is congruent to angle 3. All right, last one. VW is congruent to AB, WX is congruent to BC, X is the midpoint of WZ, C is the midpoint of BD. Okay, I want to prove that the whole long segment VC is congruent to AC. Now these first three pieces are all given information from my problem. Now, my next one, that WZ is congruent to BD. How do I conclude that? Well, if X is the midpoint of WZ and C is the midpoint of BD, I would find the whole length of WZ by taking WX times 2, and I would find the whole length of BD by taking BC times 2. And if those are congruent segments, then that result is going to be congruent by the multiplication property. So now I'm down to 2 statements and 2 reasons. Number 6, remember I'm always going to end with what I was being asked to prove, that VZ is going to be congruent to AD. So how do I wrap this up? What piece of my given information have I not used? Well, that would be this last set of congruent segments, that VW is congruent to AB. I need all my given information. And there's a quick typo there. That should be a W. That should be a B. So on 5, that was given. Now, how can I confirm that I have enough information to show VZ is congruent to AD? Well, what makes up those 2 segments? VZ comes from taking VW plus WZ, which I've shown earlier are congruent to AB and BD. So that is going to be my addition property. And that wraps up our first set of notes covering 2-column proofs. You've now done 3, so give yourself a pat on the back. Your homework involves similar to 1 through 4, where you're giving the statement of which property it is with something telling me what you're adding, subtracting, multiplying, or dividing. And then you also have some proofs. So use this as a resource, use your dominoes, and come see me if you have any questions.